Welcome to the second of 3 videos covering chemical quantities and the mole. This is a continuation of, as of right now, Unit 9, Standard 1. And in this video, we're going to be discussing molar mass, which is the mass in grams of 1 mole of a substance. So if I were to give you 6.022 times 10 to the 23rd atoms of a substance, the molar mass would be how much that weighed in grams. The units that we use for molar mass are grams per mole. So when we are discussing molar mass and determining molar mass, you can either determine the molar mass of elements. This is a little bit easier than determining the molar mass of compounds, because for elements, all you have to do is look at the periodic table. The atomic mass listed on the periodic table is also the molar mass for that element. So, for example, 1 atom of carbon, right? Think tiny, 1 tiny atom of carbon weighs 12.01 AMU, 12.01 atomic mass units, but a mole of carbon, which is 6.022 times 10 to the 23rd carbon atoms, weighs 12.01 grams. So 12.01 AMU versus 12.01 grams, or 12.01 grams per mole, 12.01 grams is a whole heck of a lot more than 12.01 AMU. But all you have to do to figure out the molar mass of an element is just look directly at the periodic table. So the molar mass of nitrogen, 14.01. Molar mass of oxygen, 16.00. And again, this number represents the mass of 1 mole of the element. So in this case, it's the mass of 1 mole of carbon. So determining molar mass for elements is very simple, as long as you look at the periodic table and you remember the units. So I've got a little challenge question for you, and I'm not going to give you the answer to this question. I'd like you to attempt it, and I'll check it later. Let's see if you were paying attention, or if you were watching this video on silent. How much does a single carbon atom weigh? All right. Slightly more complex, but really still fairly simple, is figuring out the molar mass of compounds. So what if instead of... Oh, I'm getting ahead of myself. Yes. So we want to make sure that you understand the relationship between 1 mole of carbon is equal to 12.01 grams is equal to 6.022 times 10 to the 23rd atoms. All of those things are equal values. Different units, equal values. That's going to be important in the next video when we start talking about conversion factors. Because to have a conversion factor, you have to have equivalency statements. Like if we're converting from inches to feet, there are 12 inches in 1 foot. That's an equivalency statement. So what I've just written here, these relationships are all equivalency statements that we'll use in the next video. Okay, now let's talk about calculating the molar mass of compounds, which again, slightly more complex, but still pretty straightforward. Compounds are made up of multiple elements. So when you're determining the molar mass of a compound, or a molecule, what you're going to do is add the molar mass of each of the atoms that make up that compound together. So you're going to add up the molar mass of each element. So if we were going to calculate the molar mass of water, H2O, water has 2 hydrogen atoms and 1 oxygen atom. So in order to figure out the molar mass of water, we're going to take the molar mass of hydrogen, which is 1.008, multiply that by 2, because there are 2 hydrogen atoms in water. And then we're going to add the molar mass of oxygen, which is 16.00. Again, I just got those numbers by looking at the periodic table. So there's 1 atom of oxygen, so we're just going to need 16.00. So when you add those together, you get 18.02 grams per mole. And notice that I used the correct number of significant figures. So I've got a little challenge here for you. Go ahead and solve for the molar mass of lithium carbonate. Let's see if you understand this process enough to duplicate it. And I'll check that later.